In this video, we're going to take a look at finding angle measures between intersecting lines. But we're going to start by looking at this problem on complementary and supplementary angles. So when we get to finding angles between intersecting lines, one thing you want to be on the lookout for is supplementary angles. So that means two angles that add to 180 degrees. And you can find those by drawing, if you can draw a semicircle that connects the two angles, right? You know that semicircle is 180 degrees. So you can use that in this problem to find x. X is going to be 180 minus 97, which is 83. So be on the lookout for semicircles. Those contain supplementary angles that always add to 180 degrees. We also want to be on the lookout for vertical angles. So vertical angles are straight across from one another and they share a vertex. So these two angles, since they're on opposite sides right across from one another, are going to be congruent, meaning they're going to have the same exact measure. Right? You can see visually these two angles are the same size. So x would be 37 degrees. So when we get to finding angles between intersecting lines, you also want to be on the lookout for vertical angles. So now we'll look at some examples. So again, supplementary angles and vertical angles are what we want to be on the lookout for. Well, let's look at this 20. If we look at this 20 degrees and we trace the two rays that make that angle, we can see that this angle over here is also 20 degrees. And if we do the same thing with the green angle and trace the two rays that open up to form it, right, we see that this angle right here is 130 degrees. And x, this orange angle, is therefore made up of 20 and 130, so together those make 150. So there we use our knowledge of vertical angles to find x. I'll show you one more way to do this one. Right here we have a semicircle, right, sitting on top of this flat line. So these three angles, 20 plus 130 plus unknown, have to be 180. Well, 20 plus 130 is 150, so this one would need to be 30 to make 180. Then, if this is 30, this angle across from it is also 30. And so if we look at this blue semicircle I'm going to draw, right, we have x and 30 together have to make 180, so x must be 150. That's another way to do it. All right, for this one we don't have any, right, vertical angles. We don't have any angles that are straight across from one another. But what we do have is a semicircle that equals 180 degrees. So x plus 105 plus 25 must be 180. 105 plus 25 is 130. So x must be 50. Next step. Let's look at this 22 degree angle. If that's 22, then this angle across from it is also 22 because they're vertical. And then we have this flat line segment AB. So we can draw a semicircle on top of it. The three angles that make up this semicircle have to add to 180. This one right here is 90. 90 plus 22 is 112. So x must be the remainder, 180 minus 112. That is 68 degrees. All right. Here, when you have a lot of lines that are crossing, they're going to produce vertical angles, right? So look at the angles you have and see if you can mark down the vertical angles. So we have a 20-degree angle right here in blue, and across from it would be this little 20-degree angle right here. And now we look at our green angle that's 80, and we look at the angle across from it, right? That's also got to be 80. And x, this orange angle, is then 100, 20 plus 80. So to recap, when you're finding angle measures between intersecting lines, look for vertical angles and angles that are supplementary.